Imagine an ocean 2 to 3 times larger than all the seas on Earth combined, hidden beneath miles of ice. A world where the surface freezes at -223 degrees Celsius, blasted by radiation stronger than Chernobyl. And yet, beneath that frozen skin, there may be life. This is Europa, Jupiter's mysterious icy moon. And its ocean could rewrite everything we think we know about the universe. The only question is, what's waiting beneath the ice? Diameter, 3,122 kilometers, almost the size of our moon. Gravity, just 13% of Earth's. A jump here would feel like a superhero leap. Average surface temperature, -160 degrees Celsius, dropping as low as -223 degrees Celsius. Orbit, 670,000 kilometers from Jupiter, completing one lap every 3.5 Earth days. Atmosphere, a whisper-thin trace of oxygen, but not the kind we can breathe. From afar, Europa shines like a bright pearl against the darkness. It is one of Jupiter's 4 Galilean moons, discovered by Galileo Galilei in 1610. Its surface is remarkably smooth, the smoothest solid body we know in the solar system. No towering mountains, few craters. Instead, it's covered in endless dark fractures, lineae, scars etched into the ice, as if the moon itself has been torn and stitched back together. These cracks hint at something extraordinary happening below the surface. Beneath Europa's frozen shell lies a differentiated world. At the center, a dense iron-nickel core. Around it, a rocky mantle. Above the rock, the defining feature, a global saltwater ocean, capped by ice 15 to 25 kilometers thick. This ocean may reach approximately 100 kilometers deep, holding roughly 2 to 3 times as much water as all of Earth's oceans combined. Why hasn't it frozen solid? Because Jupiter's immense gravity pulls and stretches Europa like a beating heart. This tidal heating generates enough warmth to keep the ocean liquid. At the seafloor, this energy could fuel hydrothermal vents, just like the black smokers on Earth's ocean floors. Around those vents on Earth, life thrives without sunlight, powered only by chemistry. Could the same be true here in the abyss of Europa? Life as we know it needs 3 things: water, chemistry, and energy. Europa has them all. Its ocean is salty, as shown by Galileo's magnetometer. Salt water conducts electricity, creating a secondary magnetic field inside Europa. Sodium chloride, the same salt in Earth's seas, has been detected on its surface, hinting that ocean water has touched the ice above. Chemically, Europa is rich. Impacts from comets and asteroids have delivered carbon-based molecules. In 2023, the James Webb Space Telescope detected carbon dioxide in a geologically young region called Terra Regio. The signature almost certainly came from below the ice, meaning Europa's ocean contains carbon, the very building block of life. Add to that salts and minerals leaching from the rocky seafloor, plus chemical energy created when oxidants from the surface meet reductants from the ocean floor, and you have the recipe for biology. But what if it's not just microbes? What if entire alien ecosystems have evolved in this eternal darkness? Creatures that are almost impossible to imagine. Europa may not keep all its secrets locked away. In 2012, the Hubble Space Telescope caught glimpses of massive water plumes, erupting hundreds of kilometers into space. Later, scientists re-examining Galileo data from 1997 found signs that the spacecraft may have flown through one of these plumes without realizing it. If true, this is revolutionary. Plumes mean that samples from Europa's ocean could be collected without drilling through kilometers of ice. Every eruption would be like a message in a bottle from the deep. But how do we look for life in an ocean hidden beneath miles of ice? Scientists search for biosignatures, chemical or physical traces that could hint at biology. Plume sampling. If plumes are active, spacecraft can fly through them, tasting the vapor and ice grains for organics, salts, or even microbial structures. Surface deposits. Materials carried upward from the ocean may freeze on the surface. Spectroscopy can reveal organics, carbonates, or amino acids. Fluorescence detection. Certain organic molecules glow under ultraviolet light. A future mission could scan Europa's ice with a UV laser, hunting for the faint fluorescence of compounds essential to life. Future landers. NASA has proposed a Europa lander that would scrape beneath the radiation-processed top layer of ice, searching directly for organic chemistry or even cell-like structures. It remains a concept, but one that could transform astrobiology. Even the absence of expected organics would teach us something profound. If Europa is barren, despite having water and energy, life may be rarer than we hope. Our story with Europa began in 1973, when Pioneer 10 flew past Jupiter. It revealed Europa only as a tiny, bright disk. Then came the Voyagers in 1979. Their images shocked scientists, a world crisscrossed by dark lines, with almost no craters. Something had erased the scars of time. In the 1990s, Galileo orbited Jupiter and changed everything. It revealed chaos terrain, salty compounds on the surface, and, most importantly, the evidence of a global salty ocean beneath the ice. To protect Europa from contamination, Galileo was deliberately plunged into Jupiter's atmosphere at the end of its mission. That act alone showed how seriously scientists took Europa's potential for life. More recently, Juno skimmed just 352 kilometers above Europa in 2022, capturing new details of its ridges and icy scars. The James Webb Space Telescope, observing from 1 million kilometers away, confirmed carbon dioxide on its surface in 2023. Step by step, the evidence mounts. The real age of Europa exploration is only beginning. NASA's Europa Clipper, launched in October 2024, is already testing its instruments in deep space, including a radar experiment during a Mars flyby in early 2025, and will gain an extra push from Earth in late 2026. On its way to Jupiter, it is steadily preparing for arrival in 2030, where it will perform nearly 50 close flybys of Europa. Equipped with radar, spectrometers, dust analyzers, and high-resolution cameras, it will probe the ice shell, the hidden ocean, and perhaps even sample the plumes themselves. Meanwhile, ESA's JWST mission, launched in 2023, has already begun its long gravity-assist journey through the inner solar system, including a Venus flyby in 2025 on its way to the Jovian system. It will arrive in 2031, with 2 Europa flybys scheduled for 2032, providing an independent perspective to complement Clipper's observations. Though its primary target is Ganymede, JWST will help refine estimates of Europa's ice thickness and magnetic environment. And beyond that lies possibility. A Europa lander, or even cryobots that one day might melt through the ice and dive into the ocean itself. The coming decades may see humanity's boldest steps yet into the alien oceans of our solar system. Europa isn't just another moon. It's a hidden ocean world that may finally answer one of humanity's oldest questions. If life exists there, then biology isn't a miracle unique to Earth. It's a cosmic phenomenon. And if Europa is lifeless, even that is profound, because it tells us where to search next.